Welcome. Welcome to tSQLt Live DevOps Edition. If you're looking to learn more about DevOps, Data Platform DevOps, or DevSecOps, you have come to the right place. In this video series, I'm talking about what DevOps is, how to get started, why it is important, and also some more advanced topics. So no matter where you're at in your DevOps journey, there's something for you here. With that, let's dive right in. Today's topic is, what is test-driven design? A few episodes ago, we talked about what unit testing is. And test-driven design is very similar to unit testing. However, there is one significant difference in that with unit testing, you generally write your tests after you have written the code, trying to make sure that what you just wrote is working. Whereas with test-driven design, you use the unit tests to guide your design, to guide your development process. And with that, you write your tests first, but not all of them, just one at a time. You go through a cycle, and with that cycle, you take small steps and you get immediate feedback about what you're doing, if that is going in the right direction. And you get a design that, because it is driven by tests, it's inherently testable. Sometimes if we write code without thinking about tests, we end up with a block of code that is really hard to test. If you do test-driven design, well, that problem won't happen to you. So let's look at what the cycle looks like. You start out by writing a test for some small thing. Like, think about you're testing a method. And the method is supposed to say add to numbers. Let's pick something simple. So you write a simple test that shows that you can pass in two numbers and that the result that is returned is also a number. You might do something like 0 plus 0 is 0. That test will fail because there is no method implementation yet. So the first step always is letting the test, write the test, see that the test is failing. That is very important, a very important part. And a benefit that you lose if you do unit testing after the fact, you see that your test can fail and that it fails for the right reason. The next step is then to just write enough of your method, of the module you're testing, to make this test pass. In this case, it would be something as simple as, and don't shy away from hard coding, writing the method stub, which takes two parameters, and returning a hard-coded 0. So really write the minimum amount of code needed to make that test pass. The third phase in the TDD cycle is refactoring. Refactoring means looking at the code you have written and see if you can do some cleanup. Cleanup would be things like renaming a variable to make it more telling as to what it is holding. Any form of renaming, but it can also contain things like pulling a piece of code out into a sub-method, into a separate method, to reduce duplication. You want to do that anytime you have used code 3 times definitely, sometimes even if you use code, the same block of code twice in your code base, pull that out into a method. And that's what refactoring is there for. Refactoring does not change the functionality. If the tests are passing before you're doing refactoring, they should still pass after you're doing refactoring. And if you hear somebody talking about refactoring a new feature into your code, that is not how you're supposed to use the term refactoring or how it is defined. Once you're done with refactoring, you write the next test. Again, a small test, adding a small piece of functionality seeing that the test fails, and writing enough code to make the test pass, refactor again, and so on. So what's the benefit of all that? Kind of mentioned that beforehand, but let's go through it again. The biggest benefit is probably code coverage. If you really take small steps like this, if you don't write any code, if you don't add any functionality to your code that hasn't been asked for by a test, then you get inherently full code coverage. Every piece of code is tested. That's a little what's the word? You might not be used to that in the beginning. It feels awkward to not just add that code that you know you will need, to not just add the first parameter plus second parameter into the return statement with that first test that only asks for a 0 to be returned. But if you follow those small steps, if you do not jump ahead, you only implement the functionality that a test has asked for, then you can be sure after you're done that all your functionality is supported, is covered, is protected by a test. The design, if you do test-driven design, tends to be more modular, easier to deal with, cleaner, better. And it also leads to inherently testable code, because the code, once you're done with it, is fully tested already. So while you can still write ugly code, if you really follow these steps, if you do the refactoring step in particular, you will end up with nice, clean design that is modular, and to the third point here, that is easy to maintain for the next person that comes around and needs to make a change to it. And that is really all that I had for you today. I hope you enjoyed this content. If you have any comments or questions, please leave them below. If you liked it and would like to see more like this, please subscribe. Thanks for watching and have a fabulous day.